This lesson is going to cover major uses of application of electrolysis. Actually, only one application of electrolysis in the industrial scale will be discussed here. However, there are three uses of electrolysis given here according to note. First one is electroplating. Second one is extraction of reactive metal from their ores. Purification of a metal. I will focus on the electroplating, and the B and C will be discussed in separate lessons. So what is this electroplating? How is it going to be important? We do this using electrolysis. There's a bit of an introduction to electroplating. What exactly is electroplating? It is about depositing a metal on another metal object using electrolysis is called electroplating. Let's read it again. Depositing a metal on another metal object using electrolysis is called electroplating. Example, copper plating, that means covering with a copper layer. Silver plating means covering with a silver layer. Gold plating, there's another name for that, it's called gilting. Gilting means covering with a gold layer, gold atom layer. Zinc plating means covering with zinc atom layer. One example is here. This is a pen, gold coated. There's a special type of pen, available in the market. Everyone knows about this. Cross pens. There are different types of pens under this category. Cross is a brand name. We have different types of pens varying from one low economical value to a very high economical value. There are pens for about 20,000, 50,000, over 1 lakh. And the value has been added for these cross pens through electrolysis, electroplating. So the A is add value to a less valuable metal object. Example, gold plating on an iron object. You don't see the gold here. We can see, you cannot see the iron here. You can see the gold because there's a gold coating. B, deposit a protective layer to prevent a metal object from corrosion. When you deposit a gold layer on this pen, the iron part is covered. Therefore, it will not undergo corrosion. And then we can have a good look also added to the object. So that's one of the objectives. So what are the three things? Why do we do electroplating? Because they can add a value to a less valuable metal object, and we can prevent a metal object from corrosion, and you can add a good look. When you do this electrolysis, electroplating, there are a few things to remember. Okay, rather than reading this, I will discuss the work with the help of a diagram. Let's take the heading silver plating and iron ring. We have an iron ring. We want to deposit a layer of silver plating and iron ring. Little by little, you can see silver deposition happening during the electrolysis of this. See, the surface of the The object is getting covered with silver. This is what we are going to do. Finally, you don't see the nature of this, the true nature of the ring. We start with an iron ring, but finally we have a silver coating. So anyone will think, okay, this is a silver jewelry, and there are some cheaters in the market. They sell this sort of things to people, and people who don't know this, they will simply go for it and suffer later. I suppose I want to make an iron ring or any object silver plated. How are we going to do it is my question now. Here, the electrolysis that can be used for this process is given on given below. Given below. Please cut that on. Pay attention to this. I'm going to construct this one step by step. You take the solution. And then we have a battery.
I have a question.
Please go ahead.
Sir, now, sir, for the battery, is there a specific voltage or something?
No, we can use any battery, normal 1.5 volt battery.
Okay, sir.
Yeah, no problem. But then if you use a high voltage, we can do this electrolysis for a longer period of time. That's only difference.
Okay, sir.
Right. Now what are we going to do? To discuss electroplating. In this electroplating, in this particular example, we are going to do silver plating on a metal ring. There should be an anode and cathode here. What happens if the electrode is reactive? At the anode, what is going to happen? What will happen to the anode if the electrodes are reactive?
The anode is going to react and dissolve into the reactor.
Anode is going to dissolve. If you have this idea, we can solve one of the most important points. It is, now, where are we going to fix this ring for this purpose of electrolysis? You said that if the electrodes are reactive, anode is going to dissolve. So remember, if you fix this iron ring at the anode, you will lose the ring because the ring will dissolve. So we never fix the ring at anode because anode dissolves. So it has to be kept in the cathode. Always a cathode should be the metal object. Metal object is cathode, means this one. The metal ring. And then if you are going to do silver plating, the solution has to have Ag plus. Electrolyte. Has to contain, in this case, silver iron. And then we go to the anode. Because you electroplate with silver, this anode can be silver or carbon. Anything is okay. However, the solution has to contain silver ions so that from the solution, silver ions can come onto the surface of the iron ring and deposit. I think these things have been given up there. Important points to remember when using electroplating. Read the first point. The metal to be plated must be used as a cathode. The metal to be plated must be used as a cathode. I have written over here, cathode is metal object. Second one. The second point up here, the metal that deposits on the metal object at cathode must be used as the anode. Or you can use carbon also for this. Third point, the electrolyte must contain ions of the metal that deposit on the metal object. Silver ions must be there. And I have included another information. The anode can be graphite if the electrolyte contains the necessary metal ion. Yeah, that's done. Anode can be silver or carbon for this electrolysis because we are going to do silver plating. Let us discuss one example under electrolysis, silver plating. Under electroplating. This is a diagram. I want to deposit silver on a metal ring. Just observe the diagram a little bit. I think we had to remove this part. You can write unreactive. Please change this. Unreactive anode. Not silver, graphite. Please change like this. And we have to write the answers for this. Shall we see? Anode half reaction. For the anode reaction, anode half reaction, here we have copper, here we have carbon electrode, therefore anode will not dissolve. Solution has nitrate ions and OH negative ions. 4 OH negative ions will participate in the reaction, liberating or giving out 4 electrons, 2 H2 and 1 oxygen. At the same time, for the cathode half reaction, we have silver ions and hydrogen ions. Reactivity series shows silver at a lower level. For the cathode reaction, we have to always use the reaction of a cation, which belongs to a lower reactive element. So for the cathode half reaction, we get silver plus electron giving silver. This is aqueous. This is solid. If you look at the first equation, it has 4 electrons. Second equation has only 1 electron. So to write the overall equation, I can say 1 plus 2 into 4. Why do I do it? To cancel the electrons and write the final ionic equation, overall equation. 4 OH minus plus on the second reaction, we have silver. But because you multiply by 4, I can write 4 Ag plus. Electrons cancel out, giving 2 H2O plus O2 plus for silver. If you write the observations at the anode, we can say the size. The size of the anode decreases gradually. Wait a minute. Here it doesn't happen because size of the anode decreases if the anode is reactive. Here anode is unreactive. Therefore, observation at the anode is gas bubbles. And observation at the cathode, silver is solid, deposits on the cathode. Changes in the changes on the cathode. No, changes in the electrolyte. You can write when hydroxyl ions and silver ions react, hydrogen ions and nitrate ions remain in the solution. Hence, acidity in the solution in the electrolyte increases. That's a very, very simple electrolysis reaction coming under electroplating. Everything that's happening during this electrolysis has been shown here. I guess this electroplating, actually to deposit a layer of silver on a metal ring which is fixed in the cathode, is something very simple to understand. Please go through this lesson several times, especially the equations here and the observations, and it will be very, very important for you to discuss past paper questions easily. So that's the end of the lesson on silver plating a metal ring.